Hello friends. So today we will see one more problem from the daily Leetcode challenge, and today's problem is decode ways. So first let's see what the problem says. So problem is a message containing letters from A to Z is being encoded to number using the following mapping, right? So we have a mapping between the characters A, B till Z and the corresponding numbers, right? So given a non-empty string containing only digit, determine the total number of ways to decode it, right? So the problem is something like this. So say suppose for input, we will have a string of digits, right? And we will have to find all the possible outcomes like the number of possible outcomes we can have if we decode that string, right? So just to give you an example, so the first example is 12. So now 12 can be decoded as, say, if we consider one as A, so 1 and B, which is AB, right? Or we can consider this number as 12 rather than considering this number as individual 1 and 2. We can consider this number as 12, and then the decoded string will be L, right? If you say A, B, C, D till 12, so the 12th letter will be L, right? So the result will be 2. So we will say if the input is 12, we can decode 12 in two different ways, right? Similarly, let's see the next example. So the next example is 2 to 6. So now I can different ways in which we can decode this. First, consider 2, 2 and 6 as individual digits. So you can decode it as BBF, right? If you are considering 2 to 2 as separate digits. The second way can be consider 2 as a single digit and 26 as a different digit, right? So it will be BC. Third can be you can consider 22 as a single digit or a single number and 6 as the remaining number. So it will be VF, right? So we can say that there are only three possible ways of decoding 2 to 6. So output will be 3, right? So the problem is very straightforward. So we will always have a string of digits and we will have to find out the number of ways in which we can decode it, right? I hope this is clear. So let's see, and there are few things which can go which are negative. So say something like 0. So we do not have any mappings for 0, so we will return 0. Similarly, say if the input is 27, so we don't have any mappings for 27, right? And we can't actually decode 27 if we are considering 2 and 7, or we can. So only one way will be 2 and 7, right? So we'll see how we can do all such cases. So I'll try to first explain how many possibilities we can have, and then how we can come up with a recurrence or with a formula of working with such problem, and then we'll go to the coding part. So first let us see the same problem which we were discussing, which was if s is equals to 27. So now we can decode 27 in only one way, which is by considering 2 and 7 as individual units, right? So it will be G, it will be P, because if we combine 2 and 7, which means 27, then 27 do not have a mapping, because remember we have a mapping from 21 to 26, right? So in this way we will have to consider two out of boundary situation, which is 0 and anything greater than 26, right? Because we will not be able to map them to any valid mapping, also we will not be able to decode them, right? So I hope now the problem is clear. Now let's see how we can solve it. So say suppose we'll try to solve it using bottom up DP, right? Dynamic programming, which is also known as tabulation. So I will try to explain these concepts also when we are looking at the problem. So I hope this video will also help you to understand the dynamic programming part of and like what is bottom-up programming. So now in this problem, if we look closely, I can say that if say s is of length 1, then we can decode s like length 1 of s in two ways, or there is two possibilities. Say if s is equals to 0, then we can't decode it, right? So the output will be 0. But if s is anything from 1 to 9, we can decode it, and we can decode it only in one single way, right? So let's create a dynamic programming table. So I'll say write dp. So if length is 1, I have two possibilities, 0 or 1. Now say suppose length is 2, right? So take length is 2. So now if length is 2, then again there are two possibilities. So if say I have something like say 12, so I can do it in two ways, right? But if say so I have something like 27, which we just discussed, I can do it in one way, right? And if say we have something like 09, we can't do it, right? Because we don't have a mapping for 0 and we don't have a mapping for 09. Don't confuse yourself saying that okay, we have a mapping for 9, right? No, but we have a mapping for 9, but what we are trying to decode is 09, and for that we don't have a mapping, right? So it will be 0. So similarly for dp2 we can have 0, 1 or 2 ways, right? So this is easy, right? You can come up with dp1 and dp2, like if length is 1 and length is 2. Now we will try to see how we can come up with more like with anything length greater than 2, how we can solve those problems, right? So let's try to solve this. So say suppose now s is something like say take say 27, right? And now I have added 8. So now we want to solve it. So s is 278. So for 278, we already know what is the answer for this, right? We know answer for this is 1. We have saved it, right? So we know answer for this is 1, and now we want to solve the answer for 278. So how we can solve that? So there are two possibilities, right? Either we can consider it as 2 and then 7 and 8 as one number, or we can say 27 is one number and 8 is individual, right? So there are two possibilities. So in this, if we are doing something like this, then we can come up with a function which by using the dp of length 1 and 2 can find out the answer for anything with length more than 2. How? So say suppose if this is the case, then we can say that the number of possibilities of this will be f n minus 1, right? Which means, or take like so this means f2. So if we are considering 8 as an individual number, the number of outcomes for this combination will be same as the number of outcomes for any 2-digit value, right? Because if say 27 is 1, then if you are adding 8 at the end, it will still remain 1, right? Understood? Okay. Now the second one is when we are adding 7 and 8, or we are considering 7 and 8 as a single unit. So in this case the answer will be same as that of the remaining length, which is 1. So it is something like 3 minus 2, and it is something like 3 minus 1. So basically what we are saying is when we are considering 7 or 8, or like say 8 is combining with the last number, then the total number of outcomes for this combination will be f n minus 2, fn minus 2. And if we are considering 8 as a single unit, then the total number of outcomes will be fn minus 1. So basically from here we can say that fn is equals to fn minus 1 plus fn minus 2, right? To simplify, I have not considered the cases where this number can be a 0, right? Or the combination of this is going above 26, right? So this I have not yet considered, but when we will be coding, we will have to consider those, right? So take one more example. Say suppose I have 1182. So this is my number. Now when we are calculating f4, which means this is 4, right? So f4, we have two combinations, whether we can consider 118 as a single unit and 2 as single, or we can consider 1 as a single unit and 82 as single, right? So which means f n minus 1 or f n minus 2, right? Now this is fine because this is not 0 and this will always be less than 9, so we will take fn minus 1. But 82 is greater than 26, right? So there can be no possible combination, so we will not consider this. So which means f4 will be equals to f3, right? So in this way we will also check the conditions where the combination is going outside of the range, right? So I hope you understood this part, right? How we are calculating dp of n by combining dp of n minus 1 plus dp of n minus 2 with some terms and conditions, right? Which we will apply based on the table of coding which we have, 1 from 26, right? So we have only these valid codes. So this terms and conditions will depend on these valid codes, right? So this approach is known as bottom up, right? Because you are starting from the lower or the smaller problem and you are moving ahead and building bigger solutions, right? So you know the solution for 0, you know the solution for 1, and then you are using those to build the solution for 5, 6 and like n, right? So this is bottom up TP. You are going from down and moving up to create an answer for n, right? I hope that is easy. Things will get more clear when we are actually coding it, because then also I'll keep explaining why we are doing it and how we are doing it. But I hope that this is clear. Please consider all these examples and remember them when we are coding. So finally let's code it. So as the first step, I will take a array which will store all the values which we have calculated, right? So it will store the answer for the number of possible combinations for a particular length. So dp of say 3 will give us the answer for the number of ways in which we can decode a string or with the string of length 3, right? So this is our store. Now let's see what will be the what will be the first answer for the ways to decode a string of length 0. So if I say caret 0 is not equals to 0, right? So if the first character is not 0, then we can decode it in one way, right? So similarly we are just saying this, right? So I hope this is clear. So I am just saying that if the first character is not 0, I can decode it in one way, otherwise I can't decode it, and so dp0 will be 0, right? So now let's calculate all the bigger strings. So this is not an array, this is a string. So we'll have to take this and right. So if so again I will check if the character, the new character which we are considering, is not 0, right? Because if it is not 0, then only I can say that we will be taking dp I minus 1 into consideration, right? Because we have just seen that uh, we can take we will be taking dp I minus 1 and dp I minus 2, but based on some condition. So for I minus 1, this is the condition: I plus cd equals to dp I minus 1, right? Now, so this is the first condition. Now for the second condition, we have like when we are saying that we are combining the last with the second last, right? So we have to now calculate the last two numbers. Right, so the first case was when we are not combining the new character with the like the previous string. In this case we are combining the last character with the second last character. So if so now our condition will be, because these are two and as per our encoding table we have characters from 10 to 26, so we'll say the same thing, and last two is less than 26, right? Or less, not less than equals to 26. Then in that case dp I will be like, we'll consider dp I minus 2 as well, right? But there is one catch here, because we are starting from 1 and we are saying dp I minus 2, so it will give us stack overflow. So I'll just say if I equals to 1, then dp I plus plus. So this case is only for the second dp of 1, right? If we are talking about zero based indexing, so this is only for that. Else we are simply saying that if the last character is not 0, then take dp I minus 1. If the last two characters are valid, then take dp I minus 2, right? So hopefully this will give us the answer, and we will just return dp length minus 1, because we are doing zero base indexing, so we will return minus 1. Let's see. Sorry for the typo. At what line? 16. Okay. Right? So I'll try to submit it. Okay, so my bad. The error was because of this. It should not be caret 0, because we should be considering the last character. So sorry for the typo. Let's again run and submit this. I hope this should work now. Cool, right? So I hope this is clear. Please let me know in case you have any doubt, and I'll try to clarify this. Thanks for watching. Bye.